All right, so actually the first few sections of this test were originally designed to be a no calculator test, but because we kind of consolidated another section from an older test, we ended up letting you use a calculator, but we've restructured some of the question design so that way, like, you really have to know what you're talking about, even if you have a calculator. So what I'm going to do is, for the graphing, I want to do as much of this without a calculator as possible, just for good practice for the SAT test. Let's take a look at this function, which, what, is it an exponential growth or exponential decay? And tell me how you know that. It's growth. How do you know it's growth? Yeah, the base is greater than 1, therefore it's going to be an exponential growth. In order to find some quality points, obviously if you have a calculator, you don't have to think really hard, but you guys could get these points without a calculator if you were forced to. So you plug in a couple of x values that make sense to you. So if you plug in 4 to the negative 2 power, that would become a 1 over 16, which is some teeny tiny decimal. 4 to the negative first power is 1/4, which is 0.25. 4 to the 0 power is 1, 4 to the first power is 4, and 4 to the second power is 16. Now, these ordered pairs, like, I don't really graph well on a good day, and a lot of these ordered pairs are kind of difficult to graph on this graph. So do the best you can. Like 2 to the 16th power is like up here, or 2 comma 16, excuse me, is way up here. I can't graph that. And then you've all learned from the master grapher here, right? Yeah, I missed my point. Okay, so here's some things I'm going to be looking for on your graph. The general shape should be decent. It should look like an exponential growth. The other thing that I expect to see, and I might suggest you use a highlighter to kind of mark it, the horizontal asymptote, which is, where is it located, by the way? At y equals 0. You should not be going through the horizontal asymptote. The tail end here should kind of be scooting along it. So you should indicate there's an asymptote, but don't get sloppy and graph it where it looks like it crosses. You should plot a few good points. I should clearly see the intercept, which is on the y-axis. Where is the ordered pair here for the intercept? At 0, 1. Very good. Notice we didn't mark an x-intercept. Why is that? There isn't one. Yeah, there's an asymptote. Domain. This is the nice one that goes forever to the left and forever to the right. So your domain starts at negative infinity and ends at positive infinity. Every day, Zach. Thanks. Your range, where's your range? You won't find one in here. Alright, so your range. Be careful on your range though, guys. It does start at 0, but we decided because of the asymptote it's not going to get to 0. So you indicate that by saying 0 up to infinity. 0 with a parenthesis. And then this next question, taking this function and shifting everything left 3 units and then down 8 units. I just want you to come up with the new function. So it starts off with y equals 4 to the x power, but if you go left 3 units, what does that look like? X plus 3, good. And then if everything shifted down 8 units, that would be a subtract 8, but off to the side of your function. You don't have to graph that, you don't have to do anything other than write the function. Alrighty. So these next two questions, kids get a little excited because we just learned about that finance app and they're like, oh, it's a finance app question. No, you're just building formulas for me. So you get to use that very bright pink formula card on your test. I have new versions of it for you that you're going to be using tomorrow, but it's the same stuff. And you're just going to build up your function for me. You're not going to have to do any solving, no calculating whatsoever. So formula, that's what I'm looking for. We have an exponential function where the time starts in 2010. The population of the bears starts at 738, and then it's decreasing at an annual rate of 4.2%. And careful here, x is the number of years since 2010. So when I go to use exponential growth or decay formula, this is obviously decay because of the decreasing. You start with 738, and then you're supposed to subtract 4.2%, so make sure you're writing that appropriately. And this is where kids screw up, because they think they're supposed to use the 2010 number in your formula, You actually don't use 2010 in your formula. They're just indicating that 2010 is where time starts for the model. X is what you're using in for time, because they want X to represent how much time has elapsed since 2010. All you're doing on that question is just that, writing the formula. You don't even have to simplify it. Just leave it. So 4 is, again, just write the formula. You don't do anything extra. It says write an expression that would calculate the future value of an account that starts with $8,200 at an annual interest rate of 3.5%. It's compounded quarterly. And then they want you to leave it in for X years. So don't get cute and creative and call time something other than X. It explicitly says X years, so use X. So the formula they want you to use off your pink formula sheet, I don't remember which version it gives you, but it's this one. It's P times 1 plus R over N to the NT power. So 8,200 is our initial value. And then 1 plus 3.5% is 0.035. Compounded quarterly, which means how many times? 4, good. And then you're up in your exponent here, that 4 shows up again. And you're supposed to multiply it by how many years have elapsed, but remember we're writing a formula that has gone by X years, so just call it 4X. So again, guys, you're not doing any calculations here. There's literally no math happening, you're just putting numbers in place of the formula. Questions so far? Alright, so that's your first section of the test. Next section of the test is complete opposite. Now we're going to talk about logarithms. So I'm going to ask you to first graph a logarithm, and I really encourage you not to even touch your calculator for this question, because even if you were to figure out a way for your calculator to help you, remember your calculator does a terrible job of graphing logarithms. So here's what I would expect you to do. I want you to graph, or at least think about the graph of the inverse to this function. Now I'm going to modify this a little bit. The one on your test is even simpler than this one. There's no vertical stretch on the one that's on your test. So for now, let's just look at log base 2 of x. I want you to think about the graph for his inverse function, which is 2 to the x power. If you were to come up with xy ordered pairs for 2 to the x power, just like you did on that first question, you'd come up with like your favorite x values. So I'm going to go -2, -1, 0, 1, 2. And I'm going to plug those into this function. So 2 to the -2 power is 1/4, so that would be 0.25. 2 to the -1st power is 0.5, or 1/2. 2 to the 0 is 1, 2 to the 2 is 4. But here's the problem, guys. We're not actually graphing the exponential function. We're supposed to be graphing the logarithm function. So you're going to take all these ordered pairs, and you need to reverse them. And then wait, there's still more work to do, so don't start graphing yet. Alright, so your new ordered pairs for the logarithm of base 2, I forgot what they were. So the first ordered pair is really 0.25 comma -2. And then 0.5 -1, 1 0, and 4 2. So if this was the test question, it would have been a simple one like this. Find the exponential points, reverse them, plot. But this question on the review, since we're doing it together, it's a little more challenging than the one on your test. There's also a number 2 in front of the function. What does that do to your function when you throw a 2 in front? It's a vertical stretch. So all of your y values are being stretched by a factor of 2. So like this ordered pair is really the ordered pair, still 0.25, but now it's going to be at -4. And this ordered pair is really a 0.5 -2. This ordered pair is still 1 0 because you can't stretch 0. And then this ordered pair will be the 0.4 comma 4. So I just want to make sure everyone's clear. That extra red step we just had to do is more challenging than what you're going to see tomorrow on the test. So if you can handle that, then you can handle the test for sure. All right, finally, those red things I just came up with, that's what we're going to be plotting. There we go. And if I was trying to use my calculator to plot a log, oh boy, that's ugly. Okay, that's not better. If I was trying to use my calculator, trying to fudge my graph a little bit using some calculator help, and I don't know anything about logarithms, I'm probably going to get this question wrong because my calculator makes it seem like the logarithm kind of stops at a certain point because of the pixels. But you guys have to remember, oh, that's not what I wanted. I want a highlighter. You have to remember that there is a vertical asymptote right here. So when you guys are graphing these by hand, make a real big deal about this tail of the logarithm coming down and scooting along the vertical asymptote. Like make it really exaggerated and go beyond the points that you're plotting for me. Obviously you're not going to plot a bunch of points that are that close to 0. So let's talk about domain. Everything here should be reverse of what we just saw in the previous question. So the domain this time is going to start at 0 with the asymptote, so use a parenthesis, and goes to infinity, but the range goes forever. Give me an equation for that asymptote line. X equals 0 is a good answer. If you said the y-axis, that's fine too. And then this time, there's only an x-intercept, which is located at 1, 0. All right, fun times. Any questions on that one? Logarithms. Okay, so there's a worksheet. I think it's titled 7.5 or something. It's a bunch of graphing logarithms. And on the back is the answer key. And while it's not a part of your homework check, I think those are really good examples for you guys to practice graphing logarithms. That'll get you really ready for that question on the test. Okay, that same log function that they originally started with, I want you to reflect it over the x-axis. And then shift everything 3 units down. So what would that do? How do you reflect over the x-axis as a transformation? A negative, where is it located? Down in front, yep, right here. And then, oops, wrong color. And then to move everything down 3 units, that means you're going to subtract 3 off to the side. Okay, as a follow-up question, what if I wanted to take that original logarithm that they gave you and shift everything, oh, jeez. Don't do this to me, tablet. What if I wanted to shift everything right 7 units and up 5 units? So I would take that original logarithm. How do you shift right 7 units? X minus 7 inside the logarithm. Very good. And then up 5 units, what would that look like? Plus 5 on the end. Very good. So all those transformations that we've been like murdering you with on those tests, like you're like, why did you make me do transformations for 3 months? This is why. Because every time we encounter a new function, we have to constantly think about all the transformations. All right, guys. Yeah, what'd I do?
I just have
Oh, yes.
if we put the parentheses around the entire thing, like 2 log to the 7, would that be wrong?
So, like the 2's being distributed?
No,
Like that?
it's
Oh.
inside. Would that be wrong?
Like a parenthesis here? No.
Around the entire thing.
Like this?
Yes. No, not the 5.
No, not the 5. So
Yes.
where would your other parentheses? Oh, this one's not here?
Yeah.
Okay. Let me think about that. Let's see. So you're going to write 2 log base 2. You're indicating this is in the logarithm. I guess that's not wrong. It's just really weird. And you know, it's all a matter of preference. Me personally, I really appreciate when you guys put parentheses around what is in your logarithm function. Because I'm the first to admit, like, we don't all have beautiful handwriting. I do not have beautiful handwriting. So I have to really, like, in order to prove to my teacher, like, I know what is in the logarithm, what's not in the logarithm, I always put the logarithm body, like, in parentheses, whatever's in the logarithm. I usually won't add extra parentheses beyond that. Yes?
I was going to ask for the original question. If we didn't have
Oh, this one.
If we didn't have parentheses around the x, is it misunderstood that?
Sometimes. Yes. So like when someone writes down -2 log base 2 of x minus 3. How would I know if you meant x minus 3 in the logarithm or out of the logarithm? And yeah, I would totally misinterpret that. So that's why I really encourage you guys to, yes, put parentheses around like that. Because one could argue the -3, the way you wrote it, because you have sloppy handwriting like your teacher, maybe it looks like it's in the logarithm. Yeah, I'm with you. All right, so here, these formulas, these are just opposite problems. So the first one is a logarithmic equation, and you're going to rewrite it in exponential form, which is the way our brains like to go. And then the second question is reversing that process and going back to logarithmic form. So first thing I do is identify who is my base. So who's the base in this question? A, very good. So the base of the logarithm ends up being the base of your exponential as well. Now, for me, dyslexia roars its head right now, and I just go, okay, I never remember formulas, but I do remember that things just kind of reverse. So after I figure out the base, the other two numbers show up in the opposite order. So it's a to what power? To the x power, good. And it equals y, very good. And now they make me do that, but in reverse. So you have an exponential, we're going to write it in logarithmic form. So first tell me who is the base of the logarithm. It's going to match the base of the previous problem. So p is the base here, which means p is the base here. So then I remember from here on out, things just kind of flip-flop. So what is inside your logarithm function? The m, I heard. Good. And then it equals, does that say r? Okay, very good. So some notational things. You know I like the parentheses around the logarithm stuff. Make sure the base of your logarithm is a little number or letter, whatever it is, and it's subscript. And make sure things are appropriately sized for your hand. I'm the last person who should criticize handwriting, guys, but like in math, things get really misconstrued if your handwriting gets sloppy on these, okay? These questions. I know we've all discovered this magical change of base thing on my calculator, and it's like the best thing I've ever seen in my life. Well, turns out you still need to know the formula, guys, because I'm going to ask you on the test, there's 2 blanks. It'll say rewrite it, and then what's your answer? So you're not going to get anywhere near a good score if you can't rewrite it for me. So here's what I mean by rewrite it. You're going to rewrite it in exponential form. Even this one, okay? So what I'm looking for is base to what mystery power gives you a 9. So that's the way your brain interprets it. Because guys, I know you got a calculator, but I'm trying to get you ready for the moment where you don't have a calculator. So this is the only, well, it's not the only way, but this is one of the ways you would do it. Guys, what mystery power is that? It's a 1, yeah. So this is the answer to the question, but this is the answer to can you rewrite it? And I'm asking you both on the test. So like here on number 10, if I asked you to rewrite it, you would say 4 to what mystery power gives you 1 over 256. Now you can still answer this without a calculator if you were put in a bit of a jam. This one does take a little bit of brain power though. How do you take a 4 and change it to a fraction? It's going to have to be a negative. And then I got to think this one is a little bit of heftier thinking problem. 4 to what power gives me 256? So it's to the power though, remember. So if you had your chart, that'd be super handy. It's 4. If you were on an SAT test where you had nothing, what you'd have to do is go, okay, well, it's not 4 squared because that's 16. And then if I multiply by another 4, that's like 64. So like logic is kind of telling me 1 more 4. That'll get me up to 200 and something. Apparently it's 256. Powers in your brain, like while I do hope you guys at some point memorize many of them, there are some that like I don't have memorized either. Like I know it's somewhere in the thousands. Like I just don't know where. So like 5 to the 4th power, that one always gets me. Is that 1025? I don't even know. 4 to the 5th power, one of those is 1024. One of them, I forgot which one. Yeah, that one, yeah. Dyslexia, see, I got problems. All right, so this next one, 11, I want you to be able to rewrite it. So the rewrite is 4 to what mystery power gives you negative 64. Any thoughts on this one? Good, it's undefined. That's a bit of a trick question. You are not going to be able to raise 4 to a power and end up with a negative 64. That is a trick question. Good catch. 2 to what mystery power will get you a 1? 0. Very good. And then here, 3 to what mystery power gives you an 81? A 4. Very good. I will warn you, there is, like we said, there's the rewrite plus the answer on that section. There's also an error analysis question on that section. So like some kid tried a question and usually that means the kid is wrong. So investigate why they're wrong and explain what the real answer is and why it's that. All right, properties of logs. So you guys should be getting more comfortable with these, and there's no harm. Well, I'm not going to say there's no harm. I will not criticize you if you are able to get the answer without showing work on these questions, because we are getting to the point in our lives where, yeah, you can do these in one step, especially the condensing ones. So I know when I condense into one logarithm, my final answer is going to be like natural log of some stuff. So when I do these questions, where my answer is going to go, I write down that. And then I kind of look through the question. And I see log plus log minus log minus log. So I think backwards with those properties. Positive logarithms are going to join forces. They're going to join up together. And they're going to be multiplied together. And they're going to be located in the numerator. But what about negative logarithms? Where are they going to be located when you condense those back together? They're going to be in the denominator. So inside of this new logarithm, up in your numerator, you're going to have to multiply these things together. And guys, I don't need you to simplify this. It doesn't look any better when you simplify it. So just call it x times a plus 4. But what's down in the denominator of that logarithm? A 3, and what else? An m. Very good. That's as clean as that question gets, so just leave it. So same idea here. We're going to condense down to a single, logarithm of base 5. So I'm going to start by writing that down. And then there's going to be a bunch of stuff in it. Your job is to figure out what the stuff is. So positive logarithm, that's a negative logarithm. This is another positive logarithm. These are going to join up to the numerator. But be careful, this time you've got this 1/2 down in front, which is really located where? This is really the power. Now for bonus points, to the 1/2 power, what does that mean? It means the square root. So for all the bonus points, you would write, this is really, instead of the square root of m and the square root of b, you just join them up and say it's the square root of mb, or bm. Now in the denominator, this negative logarithm, his stuff is in the denominator, so it's divided by 7. If you wrote m to the 1/2, b to the 1/2 instead of square root, there's nothing wrong with that. It's just be careful, like if you're ever on a multiple choice test, like I don't know, your SAT, they won't write m to the 1/2, they'll write it as a square root. Questions? Alrighty. This time we're expanding. So again, I really appreciate parentheses around the stuff that's in the logarithm. So if they don't have parentheses, I go ahead and put them. Can you look through that logarithm and tell me how many terms we're going to split up into? I see a 5, I see an x, and I see a 4th root of b. So how many logarithms are we splitting up into? 3 of them, yeah. So you're going to have log base 7 of 5. And then when you're splitting up a multiplication problem like this, it becomes addition, yeah? So log base 7 of x. And then we're still adding because we're still multiplying these all together. Oops, I need a little space though. Why do I need a little space? We got a power, huh? So we have log base 7 of b, but y'all were telling me that this b, 4th root of b is really b to the 1/4 power. So that 1/4 power is going to come down in front of his logarithm. That's how you know you're fully expanded. Every logarithm is, basically you have individual logarithms with only one thing inside of them, and there's no more powers. All the powers have been brought down. So on 17, again, I really appreciate when there's parentheses around the logarithm stuff. Anything in my numerator, those are going to indicate positive logarithms because they're adding together. But things that are in my denominator are going to indicate negative logarithms because you are subtracting them. All right, here we go. I need some more room though. So let's start with the numerator stuff. Positive logs. We have common log of 9 plus common log of Hey, instead of writing x to the 4th power, where should I write his power? Down in front. Yep. Now these next two logarithms are from terms that are in the denominator, so they're going to be subtracted, both of them. So we have subtract log of 8, and then because we're still in the denominator, another subtract, leave a little space. Instead of writing y squared, where are you going to write that squared? Down in front of his logarithm. Very good. So that's what it looks like to do them in one step. If you feel ready for that, continue practicing that way. If you're like, ooh, that's a bit of a stretch, especially on a test where I don't want to get a bad score, then don't do it in one step. Do it in several steps. Like in Algebra 2, you guys used to first separate the numerator and denominator, and then you'd pull everything apart after that. So like in Algebra 2, that question probably would have taken a kid like 4 steps when they first learned it. I have no problem with you guys skipping steps on these. If you're getting them right, if you're not getting them right, you might want to go back to steps. Right here. This is like, this is the question that Chloe asked me on that bookwork. I really liked that question because like there's one almost identical to it on your test. So this is the section that you're looking at on your test. You're supposed to be doing these without your calculator, by the way. Oh, good. There's a couple of ways we can do this. So leave the 4 in front and let's investigate this part right here. You can either just investigate log base 5 of 25 and then square that answer. Well, kind of square. Or you could change it to have a matching base. They're really the same property. So for most kids, what they end up doing is they rewrite 25 as a 5. So that way they can use that cool canceling property. So they'd write log base 5 of, how do you write 25 if it's supposed to be a base 5? 5 squared, very good. Now this is a little confusing, guys. Remember, you got a power on top of a power, which means you're supposed to multiply those together. This is a really good prep for your SAT. I love this question. All right, so we got, this is really to the 4th power. But guys, what happens with log base 5 of 5? These cancel. So the 4 is going to drop down. You really have 4 times 4. Your answer is really 16. That was not even close to the only way to get the right answer. You could have squared 25 and then said like, okay, 4 to what power gives us 625, and then multiplied that answer by 4. I mean, there's a multitude of ways you could have done that. The rule is none of them are wrong because they're all stemming from the same process and same formulas. All right, this next one, a couple of ways you can do this one. For instance, I think you know what the square root of 16 is. That's 4, isn't it? So log base 2 of 4, you could rewrite 4 as a 2, or you could go back and think about the property of switching this to an exponential. You could ask yourself, like, 2 to what power gives me a 4? So the answer is going to come out to 2, regardless of what method you choose to attack that question with. And I know some of you are like, well, my method is to type it in the calculator. Throw your teacher a little bit of gratitude on your test tomorrow and show me some things on your paper before you type it in the calculator, okay? All right, so here, let's investigate. Leave that 4 alone for a minute. Let's talk about log base 3 of 9. Think of that in a brain-friendly notation, guys. 3 to what power is going to give you a 9? That'd be a 2. So this part of the problem really says 4 times 2. This is such a good SAT question on the no calculator part, of course. Minus 5 times, all right, guys, investigate this logarithm with me. Log base 3 of 3 to the 5th power. What happens there? That's just equivalent to a 5, isn't it? So let's see if I can get this one right. 8 minus 25 is negative 17. Perfect question for the gridded response no calculator SAT test. Awesome question. And then 21, again, there's a multitude of ways you could do this one, guys. For instance, I know what the cube root of 64 is. I think it's 4. I spoke a little too soon. Is it 4? Yes. All right, so we have 5 times the log base 2 of, that's really a 4. So ignoring the 5 for a minute, investigate that logarithm. 2 to what power is a 4? That'd be a 2. So your question really just says 5 times 2, so your answer is a 10. Hey, with that test being so short tomorrow, maybe do a little no calculator action and then maybe check your answers on the calculator, eh? Really get bonus points in my heart. Not on the test, of course, but in my heart. All right, let's take a look at, oh, finally, your new favorite thing, the finance app. Miss Ruby, they all know how to buy houses and cars now. And y'all know what not to do, right? We talked about this. Don't buy cars when you're pregnant. Don't buy houses at the peak of the market. And don't have children. Got all those rules? Okay, good. First, don't give your children any money. Grandma can do that. That's what I say. Oh, we joke. First hour made an addendum to that. They said, also marry rich. And I said, these are all great pieces of advice. I mean, why not? All right, so Raquel is going to deposit $375 each month into a retirement account that pays 3.2% interest. What's the value of the annuity after 20 years? So because she's depositing every month, you have to use that finance app on your calculator. So this number here, that's going to be the monthly payment. So in your finance app, I think the first thing it asks you for is N. So you're paying monthly, or she's paying monthly for 20 years. And then remember, on this app, it's kind of weird. When they ask you for interest, they just want you to leave it as like the 3.2. They don't want you to do any converting. What's next in the list? Is it present value? Okay, so she doesn't have any money yet, so her present value is 0. And then payment, I think, is the next thing. So every month she's paying an additional $375. Now the future value is what we're trying to solve for. So we're not going to do anything with that one yet. And then it's the payments per year, which is monthly, and then compoundings per year for interest, which is also monthly. These are going to match. And then make sure, remember how it's beginning versus end, make sure you guys have end highlighted. Don't go to the beginning of the month because you'll get a slightly different answer for a lot of these. Once you get that all filled out, put your cursor in the future value and hit alpha enter. And that's how they solve them. How much money does Raquel have? I'm sorry, I didn't hear that. 55 cents. Wait, what? 8.40. Oh, my bad. That makes all the difference. Oh, Raquel, you don't have enough money to retire. You poor thing. Well, it's probably because she only worked for 20 years. That's a bummer. Go back to work, Raquel. All right. This next question, technically you don't have to use the app. Can you tell why you don't have to use the app? There's a component to this missing where you have to use the app when you pay something every month. Are we paying something every month here? No, we're just collecting interest. So if you want to go old school and solve this like an Algebra 2 kid, you sure could. And you would use that A equals P times 1 plus R over N to the NT power formula. Now remember, if you're using a formula, you do have to convert the interest rate to a decimal. Now be careful, guys. They're doing quarterly this time. So it'd be like 4 times 17 up here. So there's nothing wrong with going old school. But I don't know about you. I kind of like this app. It's pretty nice. So if you're using the app on this question, 17 years, but be careful, it's quarterly on this problem. So it's times 4. And then her interest rate is 6.1. Because we're not putting anything in every month, the payment is 0. The present value, Grandma deposited $4,000, so that's your starting value. The future value is what you're going to solve for. And then be careful, guys. The other thing that changes here is the payments per year and the compoundings per year are both going to be 4. Because it's quarterly. Usually our problems in this section were not quarterly. So either way, you get the same answer, guys. And what is that answer? It's like 11,000 something. 11,000. Is this the N99 cents? Grandma, give me that extra penny. All right. So then my favorite question, the mortgage question, the really disturbing question. This time you need to first calculate the monthly payment for your mortgage. So for N, we are holding this loan, we're paying monthly for 35 years. The interest rate is, oh my gosh, 11%. That's huge. Oops. Present values first. I always forget what order it comes in. All right, present value for a loan is how much you take from the bank. So presently it's $165,000. The payment is what we're going to solve for, so leave that alone for a minute. We'll come back to that. The future value, how much should your loan be worth at the end of this? Better pay down to 0, and then make sure both of these are changed back to 12s because we're going monthly again. I need you guys to tell me what the monthly payment is. It's pretty substantial. This is a big loan, big interest rate. One more time, I'm sorry. 98 cents? Okay. So now, how much did you actually pay for this house? Well, you paid $1,545.98 times 12 months every year for 35 years. Guys, this comes out to like $600,000 or something. You paid a lot for this house. But that's because you paid a huge interest rate for 35 years. That was silly of you. You should have refied. Lesson learned. All right, I don't know what that came out to, but I'll post the answer key, guys. All right, thanks. Oops.